Assalamualaikum and hi everyone. In this video, we're gonna be shading Venn diagram regions. This is useful if you want to organize information. Maybe some words problem like this. We're gonna start off pretty basic and then work all the way up in difficulty. So let's look at the first one on the top left. If you ever asked to shade E, it's not just E only, but all of E. We're going to shade all of the part A, even that part goes to B. Now, if you look at below, you have to shade E prime, which is E complement. What E complement is, it is opposite of E. So if you look at both of these, you will look at opposite. It's going to look like everything. It's going to look everything except E. So now we'll move on to the next one, which is E union B. What that tells us that to do is to shade everything in both sets. We're going to shade everything in E as well as in B. All of A gets shaded as well as all of B. Now let's look at E union B prime. We have the opposite of A union B. So you have to know to shade the opposite of what we just did, which is everything on the outside of the two circles. Now A intersect B. Whenever you see this symbol, it is two sets have in common what they share. Look at the diagram. The shade in the middle here, that is E intersect B. So of course, we have to shade this region. Now E intersect B prime. So this is exactly the opposite of what we just have done before. So we have to look at the opposite of this area, which is everything outside the middle region. Now we're going to set up the difficulty a bit. Move on to some little bit harder. We're going to do the one with union first. Here we have E prime union B prime. We can shade everything in E prime set by set because it is union. So everything outside E as well as everything outside B. So A prime union B prime, the only thing that we didn't get shaded is just the middle here. In conclusion, with union, the kind of easy if you think of it as step-by-step instruction. First, shade everything in the first step and then shade everything in the second step. All the shaded region is E prime union B prime. E prime intersect B prime. Intersection. They are a little bit trickier. If you see the intersection, you cannot immediately visualize what the two sets have in common. You might want to do a little scrapper. So off to the side, I'm going to draw a little Venn diagram with E and B. E prime looks like this. And B prime will look like this. And then what was shaded in both? The only thing that shaded in both A prime and B prime, what they share is the outside of the two circles. Therefore, A prime intersect B prime is outside of E and outside of B. Now let's look at both on the top diagram here. We have E intersect B prime is actually equals to E prime union B prime. The shaded region for the first diagram, the shaded region is outside the middle part. Same goes here. So we can see that E intersect B prime is equal to E prime union B prime, as well as the two bottom here. We can see that the first diagram on the left same as the second diagram here. The shaded region is outside the two circles. So what we can conclude is A union B prime is equal to A prime intersect B prime. So these two are De Morgan rule. Example 8. Two events A and B are such that PA equals 0.4, PB equals 0.7, and PA union B equals 0.9. Part A. BA prime is equals to 1 minus BA. Given that BA is 0.4, so BA prime is 1 minus 0.4, which is equal to 0.6. Part B. Find the probability when A intersect B. By using the formula of additional rule, A union B equals to BA plus BB minus BA intersect B, we rearrange the equation so that probability of A intersect B as the subject. Substitute all the given values, 0.4 plus 0.7 minus 0.9, we get probability of A intersect B as 0.2. Part C, find the probability of A intersect B. From the Venn diagram, PA prime intersect B is equal to PB minus A intersect B. Therefore, 0.7 minus 0.2, we get 0.5. Here are the example for you to try and practice. Example 10. If a class with 100 students of whom 20 are studying mathematics, 15 are studying chemistry, and 8 are studying mathematics and chemistry. If we choose a student at random, find the probability that the student A studies mathematics. So we take out the information from the question. The number of students is 100 and number of students that taking maths is 20, number of chemistry is 15, and the intersection between both courses is 8. Solution. Let's start off by drawing the Venn diagram. Firstly, we have to look at the number of intersection between both events. So we put 8 in the middle here. Since the number of students taking maths is 20, so for this region, it is actually 20 minus 8 equals to 12. Okay, now for the set C, since the total students that taking chemistry is 15, take away 8. 15 minus 8 is equal to 7. So from all the students, 100 minus 12 minus 8 minus 7 equal to 73. Part A, find the probability that the student studies maths. So from the Venn diagram and also the formula of probability NE over NS, we can see that the total of students taking maths is 12 plus 8, which is 20 over 100, equal to 1 over 5. Part B, find the probability that studies both maths and chemistry. So we have to look at the region that both sets overlap each other, which is 8. So 8 over 100. Simplify it, we get 2 over 25. Part C, find the probability that the student studies either maths or chemistry. This event represents M union C. The keyword or represents the symbol union. The formula is P M union C is equals to N M union C over NS. So from the Venn diagram, we can see that M union C is 12 plus 8 plus 7 over the sample space 100, which is equal to 27 per 100. Part D, find the probability that the student study neither maths nor the chemistry, meaning that this is the complement event of M union C. So from the Venn diagram, it is just 73 over 100. Thank you.